Our problem of study focuses on Apple's Face ID, also known as facial recognition, to unlock the iPhone. However, during the pandemic, it's really difficult for users to use Face ID wearing masks on. Due to the current climate of COVID-19 pandemic, masks are required and utilized often by workers who are likely to be working remote. A typical interaction goal between the user following CDC-approved guidelines of wearing a mask and the iPhone is easy entry in unlocking and accessing the applications on their iPhone X or 11 they must use for work. The options available for opening an iPhone are facial recognition or typing the password on keyboard display. While wearing a mask, the user's phone does not recognize their face in order to open their phone. Hence, he or she must take the time to enter their password in order to access the applications they need for work. If the iPhone does not successfully detect the user's face or they do not successfully type in their password, the user must try either option again or they will be locked out. The user is delayed in gaining the access to vital information necessary from their phone in a remote work environment, leading to user frustration. This inconvenience in the automatic entry due to the inconsistency in facial recognition causes a failure in reaching the user's goal. Applications accessible on the iPhone are highly used in the corporate world today, as individuals need to access the specific context in a quick manner. The delay or inconvenience Face ID is creating causes a disruption within the workday, ultimately leading to a frustrated user who is less likely to use this or other Apple products. Given the situation in which we don't know when COVID-19 is going to be over, it is crucial for Apple to create alternatives to facial recognition or Face ID in the newer iPhones. The users affected by the problem of study can be generally stated as iPhone users. In order to be more specific and narrow down our selection, we will focus on iPhone users in the United States. Particularly, the COVID-19 crisis is transitioning more and more students and working individuals to remote learning and working environments. Assuming iPhone users follow the CDC guidelines of wearing a mask in public places, the facial recognition issue addressed in the problem of study impacts not only remote workers who own iPhones, but the general population that own the iPhone 11 and X. There are a plethora of tasks and options an iPhone user can perform, but to stay theme relevant, we will focus on the apps related to remote working. Other than iMessage, email, calendar, and contacts, the iPhone's iOS store provides many meaningful applications that many companies and classes require. For example, task-related applications include Yammer, Slack, Google Hangouts, Trello, Zoom, Duo Authentication, and more. In the case that a user must leave their home to run an errand while working, their iPhone may be the only source of access to work. By developing a solution to the problem of study, users will benefit by gaining faster and more reliable access to their application necessary for work, ultimately reducing the response time in the unlocking of the iPhone. Managing time and organization with a structured schedule is a vital aspect to remote working. In addition, the issue discussed in the problem of study can easily hinder interactions and users' focus during long processes. Little time inconveniences can add up, creating a downward spiral. By providing a solution that maneuvers the insufficient option of unlocking the iPhone via Face ID, the users can save time and effort in the other choices available in unlocking phones subconsciously, ultimately creating total satisfaction. The importance of a solution can be highlighted by the following. It is estimated that 25 to 30% of the workforce will be working remotely multiple days a week by the end of 2021. Likewise, use of masks and remote working will likely increase in the future, creating a greater need for an alternative feature for unlocking iPhones. If we can work on creating an efficient way to unlock the iPhone, it can yet again be successful within remote work today.
So for our study, there are a few solutions already out in the open. In relation to Apple, they have a low-cost iPhone called the iPhone SE, which gives you access to Touch ID, which lets you have a more secure phone, just being able to just open it with your finger instead of your face. But the thing is with that phone is since it's a low-cost phone, it's not going to be able, you're not getting the sleek and updated Apple design look that you would get like on an 11 Pro Max, or with the update for iOS 14 and continuously, you're not going to get all the things that are capable from that update on a lesser version phone like the SE. And if you go towards the Samsung side, they have, the newer Samsung S20 Ultra. They give you 3 different ways to unlock your phone with your Face ID, Touch ID, and just be able to add a traditional password. And with that, it's neat and all, but the thing is, when you open the phone, it actually gives you all 3 ways to unlock the phone at the same time, which can be very confusing to the user. In comparison to iPhone, when you you open your iPhone, it'll first, try to scan your face, or, if you're using Touch ID, it'll request your fingerprint first. And if that doesn't work, then it'll say, okay, enter your password. But that's not how it works in Samsung. It'll, just keep flashing all 3 different ways to unlock your phone until, it's unlocked. So, yep.
The mentioned solutions follow Guideline 403 regarding biometrics. Guideline 403 specifically states that biometrics, such as fingerprint or Face ID, cannot be the only means of user identification or control. If Touch ID is added to the lock button, there are still other means that users can get control of their Apple devices, such as passcodes or just a regular password. Additionally, Touch ID follows all of Norman's principles of good design. Touch ID is on the side of the phone, which is very noticeable, and the UI walks new users through setting up their Touch ID, making the solution very discoverable. Feedback takes place when a user successfully unlocks their phone through Touch ID, or the screen shakes saying it was unsuccessful. This allows users to know instantly whether they're in or they need to adjust some settings. The setup walkthrough and lock button act hand in hand to signify to users the functionality and purpose, and the solution affords to allow users to unlock their phones quickly with a tap of a button. Additionally, the side button acts as a lock and a Touch ID, which wouldn't be possible without sufficient mapping and constraints.
Based on points from A and B, we propose a solution. The proposed design provides a button on the side that can be used simultaneously as a power button and Touch ID. Buttons may have small inscriptions so that the user can recognize that it is on interface for power and Touch ID. This solution is very similar to what was used in Samsung's products and to the new features of Apple's new iPad. However, it can differentiate itself because it has a better signifier with inscription on it so that users can access it more easily. Also, it will be different from the design of the new iPad because only the power button used on the side will be used without the whole interface.
Success can be measured through Norman's principles of good design. First, visibility. Visibility can be determined based on whether or not the user can discover the button on the side and also the inscription on the button. Second is feedback. The user can get feedback by using the Touch ID function. If the user uses the function correctly and the Touch ID function works properly, then the user will be able to unlock the phone. If the user doesn't use the function properly and the function doesn't work in the first place, then the user will not be able to unlock the phone. Third is affordance. Affordance will be determined based on whether the user is able to identify the signifier and use the function properly. Fourth, mapping. The evaluation for mapping can be based on whether or not the user can make use of the function conveniently through the placement of the button, which is the button on the side. So regardless of the handedness of the users need to be able to use the Touch ID function properly and conveniently. Fifth, constraints. The constraints for the Touch ID function can be determined if a certain form of user interaction with an interface is restricted. If we were to evaluate our proposal based on this criteria, then we would say that our proposal removed the constraints for iPhones, the existing iPhones. This is because the current iPhones, the newer ones, only have a passcode function or a Face ID function to unlock the phone. So if we propose a Touch ID function, then it will remove the constraint for users who are wearing masks. Lastly, consistency. The design of the Touch ID function that we proposed can determine consistency. If users, regardless of their cultural backgrounds, can recognize the inscription that we proposed, then it will be a consistent pattern. If users from a certain cultural background or a certain background cannot recognize the Touch ID design, then it'll propose a inconsistent pattern and it'll cause confusion.